Good evening, and welcome back to SleepWise. Tonight, we begin our journey with the breath of the earth itself. Carbon is the fourth most abundant element in the universe and the basis of all known life. Born in the hearts of ancient stars, it was scattered across space and incorporated into planets and living creatures. On Earth, carbon moves through a vast cycle. Plants absorb carbon dioxide and convert it to sugars. Animals eat plants and release carbon back to the air through respiration. Microbes break down dead matter. Oceans absorb and release carbon, and volcanoes slowly vent it from deep rock. Earth is essentially a closed system for matter. The atoms that make up our bodies and our air have been circulating for billions of years. Carbon dioxide is a greenhouse gas that helps maintain our planet's temperature. Too little, and Earth would freeze. Too much, and it would become a furnace. For millions of years, the carbon cycle kept atmospheric levels relatively stable. Natural sinks, such as forests, soils, and oceans, absorbed roughly as much carbon as was released. Forests and grasslands capture about a quarter of the carbon dioxide emitted by human activities, while oceans absorb roughly 30%. Before humans, carbon moves slowly through these exchanges, taking thousands of years to be locked away as coal or limestone, then returned by tectonic uplift or volcanic eruptions. In this opening segment, imagine yourself as a carbon atom drifting through deep time. You have spent eons inside a seashell, been buried as sediment, then released as a molecule in the air. You have been inhaled by a dinosaur and exhaled by a tree. This perspective brings humility. Carbon's versatility comes from its ability to form long chains and rings. These chains are the backbone of DNA, proteins, and carbohydrates, the molecules that make up our bodies. In diamond, it forms a lattice so hard it can cut stone, while in graphite, it forms soft sheets used in pencils. These forms remind us that the same element can be strong or fragile, opaque or transparent. Our modern lives are built from the same atoms that once flowed through ancient forests and primordial oceans. Tonight, as you relax, feel your breath connect you to this timeless cycle. Each inhale is borrowed from plants. Each exhale gives back to the atmosphere. Even the carbon in our bones and skin was once part of a star. Let the pace of your breathing align with the slow rhythm of the carbon cycle. There is no rush, only continuity. The story ahead will move through time and space, but it will always return to this simple exchange, the inhale and exhale that links us to the stars. As you listen, you may sense an invisible thread connecting you with every plant, animal, and cloud that has ever breathed, reminding you of your place in the tapestry of life. In the second chapter, we shift from geologic time to human time. For most of Earth's history, carbon cycled slowly. Plants and algae captured carbon dioxide and stored it in biomass. Over millions of years, some of this material was buried and transformed into coal, oil, and gas. For ages, these fossils lay trapped underground, carbon locked away beyond the reach of living creatures. When early humans learned to control fire, they released small amounts of carbon by burning wood, part of the short carbon cycle. The smoke from hearths was quickly absorbed by nearby trees and soils. This changed dramatically during the Industrial Revolution. Prospectors discovered coal seams and oil, reservoirs that contained carbon accumulated over hundreds of millions of years. In pursuit of light, heat, and mobility, humanity began to burn these deep reserves, releasing carbon back into the air at a rate far faster than natural systems could absorb. The scale of this release is staggering. Since 1800, atmospheric carbon dioxide has risen by more than 50%, reaching about 422 parts per million in 2024. Carbon dioxide now accounts for around two-thirds of the warming influence from human-generated greenhouse gases. Methane, nitrous oxide, and sulfur hexafluoride have also increased. Burning fossil fuels has provided electricity, transportation, and economic growth. But it has also tipped the balance of the carbon cycle. Natural sinks still absorb a significant portion of emissions, but the remainder accumulates in the atmosphere, trapping additional heat. Forests, grasslands, and soils continue to take up about a quarter of our emissions, while oceans absorb roughly 30%. Yet even these vast systems cannot keep pace with our appetite for fossil fuels. This is not a moral judgment of the past. Those who built factories and railways did not intend to change the climate. They sought warmth, jobs, and progress. Yet the consequence of concentrating millions of years of stored carbon into 2 centuries is clear. The atmosphere responds to physics, not intentions. Understanding this context invites compassion and responsibility. We inherit a world shaped by choices made long ago. Our task is to find better ways to power our lives while respecting the planet's limits. In the coming sections, we will explore the greenhouse effect in more detail. Look at how scientists measure past climates and discuss what modern data say about emissions. For now, breathe in awareness that the air around you carries the memory of coal, fires, and candle flames, of forests burned and oil refined. Breathe out the intention to listen and learn. The story of carbon is, at its heart, a story of relationships between human desire and natural law, between the past and the future. To change that story, we first have to understand it. In this part of the night, we unpack the invisible blanket that warms our world. Sunlight bathes the earth, and some of that energy is absorbed by land and water, then re-emitted as infrared radiation. Greenhouse gases, primarily water vapor, carbon dioxide, methane, and nitrous oxide, absorb a portion of this outgoing heat and re-radiate it, warming the surface. This natural greenhouse effect keeps our planet's average temperature above freezing and enables liquid water to exist. Without it, the Earth would be an icy sphere. Problems arise when the concentrations of these gases increase beyond their natural range. Carbon dioxide, though a trace gas, contributes roughly 2/3 of the warming influence from long-lived greenhouse gases. Its concentration has risen from about 280 parts per million before industrialization to over 422 parts per million today. Methane, produced by wetlands, livestock, and fossil fuel extraction, now stands at more than 1,020 parts per billion, up from pre-industrial levels. Nitrous oxide, released from fertilizers and industrial processes, has climbed to around 338 parts per billion. Even tiny amounts of sulfur hexafluoride, used in electrical insulators, linger in the atmosphere for millennia and trap heat efficiently. Understanding these numbers can feel daunting. It can help to visualize the atmosphere as a thin skin around the planet, just 10 kilometers thick in terms of the layer where most weather occurs. When we add greenhouse gases to this skin, it is like thickening a blanket. The effect does not stop all heat from escaping, but it slows the rate of cooling. Climate scientists have built complex models to simulate how energy flows through the Earth system. These models incorporate the interactions among ocean currents, cloud formation, ice sheets, and vegetation. They show that increasing greenhouse gases shifts weather patterns, intensifies heat waves, and disrupts precipitation. Still, the greenhouse effect itself is not a villain. Without it, Earth would resemble Mars. The challenge is the imbalance. We are adding greenhouse gases faster than natural systems can adjust. When you hear statistics about parts per million, remember that they translate into real changes. A hotter day here, a stronger storm there, a shifting migration somewhere else. The greenhouse effect is also a teacher, showing us that the atmosphere responds to our actions. With that knowledge comes agency. By reducing emissions and strengthening natural sinks, we can restore balance. As you breathe out carbon dioxide tonight, know that it will be taken up by a plant or dissolved in the ocean. The gases that worry us are not the gentle puffs of breath that sustain life, but the torrents of fossil carbon released by industry. Hold that distinction gently and let it guide our next steps. To understand how the atmosphere has changed over centuries, scientists look to ice and air. In Antarctica and Greenland, layers of snow accumulate year after year. As snow compresses into ice, it traps tiny bubbles of the air that existed when the snow fell. By drilling deep cores, researchers can extract these bubbles and measure ancient concentrations of greenhouse gases. They find that carbon dioxide levels oscillated between about 180 and 280 parts per million over the last 800,000 years, rising during warm periods and falling during ice ages. The modern spike to more than 420 parts per million has no analog in this record. Instruments on mountaintops and satellites now monitor the atmosphere continuously. These tools provide a global perspective on emissions and their trends. The most recent assessments show that in 2024, energy-related carbon dioxide emissions reached roughly 37.8 billion tons. While still huge, the rate of increase has slowed to about 0.8% compared with the previous year. This decoupling of emissions from economic growth suggests that some countries are able to expand their economies while limiting pollution. Natural gas and coal were responsible for most of the emission growth, reflecting increased use in power generation and industry. Natural gas consumption jumped and coal use crept up as well, signaling that fossil fuels still play a large role. Regional patterns are diverse. Emissions rose in emerging economies, particularly in Asia, as industries and populations continued to grow. They declined in many advanced economies where efficiency, renewables, and structural shifts reduced fossil fuel use. These patterns show a world in transition. Old habits persist, but new technologies and policies are beginning to bend the curve. Understanding these numbers is important, not to induce guilt, but to provide context. The billions of tons emitted each year are the aggregate of countless daily decisions. The flick of a light switch, the filling of a fuel tank, the operation of a cement kiln. We are part of that aggregate. Seeing the scale can also inspire awe. Imagine the atmosphere as a bank account. For centuries, the balance remained steady. In recent decades, we have made huge withdrawals. The Earth's response, warming, melting, shifting, is a form of accounting. When we see emissions start to plateau or decline in some countries, we glimpse the power of collective effort. In this segment, take a moment to appreciate the scientists who spend winters on ice sheets, the engineers who design emissions monitors, and the communities who push for better data. Their work provides the mirror in which we can see ourselves and choose a different path. Having looked at emissions, we turn our attention to the systems that absorb carbon. Forests, grasslands, and soils act as vast sponges. Through photosynthesis, plants convert carbon dioxide into wood, roots, and leaves. When they die, some of that carbon becomes part of the soil. Microbes break down organic matter slowly, releasing nutrients and storing carbon in humus. These terrestrial sinks currently absorb roughly a quarter of the carbon dioxide emitted by human activities. Oceans, covering more than 2/3 of the planet, absorb about 30% carbon. Dioxide dissolves into surface waters and is used by phytoplankton to build shells. Some sinks to the deep ocean, where it can remain for centuries. However, increasing concentrations of carbon dioxide are making the oceans more acidic, which can dissolve shells and harm marine food webs. Warming waters reduce the solubility of carbon dioxide, creating a feedback loop. Nature's capacity to absorb carbon is not unlimited. Deforestation and land degradation reduce the ability of forests and soils to sequester carbon. As trees are cut and burned, not only is stored carbon released, but the sink itself is diminished. Reforestation and soil conservation can help restore these capacities. Protecting mangroves, peatlands, and kelp forests offers outsized benefits. These ecosystems sequester carbon at high rates while providing habitat and storm protection. The health of sinks is tied to biodiversity. A diverse forest is more resilient to pests and drought, and diverse ocean ecosystems can better adapt to changing conditions. Emission patterns also vary greatly among countries and individuals. Over the past 50 years, global emissions have risen rapidly, but per capita emissions differ by orders of magnitude. In some wealthy nations, emissions per person have declined since the 1970s due to efficiency and policy, yet the absolute level remains high. Many low-income countries emit very little carbon per person, but face the brunt of climate impacts. This disparity highlights the importance of equity in climate solutions. Actions such as switching to renewable energy, reducing meat consumption, and improving public transportation have very different implications depending on a country's starting point. Understanding these differences prevents unfair blame and informs fair cooperation. When you hear global numbers, remember the mosaic of individual lives and landscapes behind them. Notice how your own lifestyle fits into this pattern. Do you live in a region with high per capita emissions? Are there changes you can make that align with the broader goal of reducing collective impacts? The path forward involves both protecting natural sinks and reshaping consumption. Both are acts of care for forests and oceans and for each other. So far, we have seen how emissions and sinks play their roles. To change the trajectory, humanity is rapidly reimagining how we power our world. The energy sector accounts for about 73% of global greenhouse gas emissions. Transforming it is essential. Investment patterns are shifting accordingly. Analysts project that total global energy investment in 2025 will reach around $3.3 trillion, with more than $2.2 trillion flowing into clean technologies, solar panels, wind turbines, nuclear power, upgraded grids, batteries, and efficiency measures. Spending on renewables and efficiency is roughly double that on fossil fuels. Solar photovoltaics alone are expected to attract around $450 billion, more than any other power source. And nuclear energy is poised to receive over $70 billion. Import-dependent countries drive about 70% of growth, reducing exposure to volatile fuel markets. Behind these numbers are policy commitments. Net zero pledges now cover roughly 70% of global emissions and gross domestic product. Achieving them will require clean electricity to supply about 90% of total demand by 2050. That means wind generation must expand roughly 11-fold and solar generation about 20-fold. The United States plans to obtain 80% of its electricity from clean sources by 2030 and 100% by 2035. Canada has legislated climate targets and employs carbon pricing and electric vehicle infrastructure to accelerate change. Such policies send strong signals to investors and industries. The era of fossil fuel dominance is ending. The transition is not just technical. It is also social and economic. Clean energy can create jobs, improve air quality, and decentralize power production, giving communities more control over their resources. Yet, care is needed to ensure that the benefits are widely shared. The shift away from coal and oil will impact workers and regions dependent on these industries. A just transition means providing training, investment, and support so that no one is left behind. The scale of change can be intimidating, but the momentum is building. Picture deserts covered in glittering panels and offshore turbines, harnessing steady sea breezes. Hydrogen plants convert excess wind into fuel. Homes with rooftop solar-charged electric vehicles quietly. These images are not distant dreams. They are emerging now in cities and villages around the world. As you drift deeper into this story, imagine the hum of a distant turbine blending with the sounds of your own breath. The energy that will power our mornings is already being generated somewhere, quietly and cleanly. Beyond changing how we generate energy, some propose capturing carbon directly from smokestacks or the air. Carbon capture and storage, CCS, involves collecting carbon dioxide from power plants or industrial facilities and injecting it deep underground into depleted oil fields or saline formations. Reports suggest that cumulative investment in CCS could reach about $80 billion by the end of this decade, and installed capacity may quadruple by 2030. Even so, by mid-century, these systems are projected to capture only around 6% of global emissions. In other words, CCS can play a role, but it cannot replace emissions reductions. Carbon removal technologies aim to draw carbon dioxide directly from the atmosphere or from biomass and lock it away. Their combined capacity could reach roughly 330 million tons per year by 2050. That is significant, but still small compared with the tens of billions of tons emitted annually. Direct air capture, DSC, has captured imaginations. Machines blow ambient air through filters that selectively bind carbon dioxide, which is then concentrated and stored or reused. Yet global DC capacity today is just over 10,000 tons per year, and most plants are pilot projects. Around 130 facilities are in the pipeline, but scaling to meaningful levels will take decades. Costs remain high, on the order of hundreds of dollars per ton, though they are expected to decline with learning. Investors look for sites with abundant renewable energy and waste heat to power these processes, and some governments offer tax credits to spur development. Still, even optimistic scenarios show DRC capturing only a fraction of what is needed. The lesson is that technology, while exciting, is no silver bullet. It must be part of a portfolio. That includes reducing emissions at the source and enhancing natural sinks, cultivating healthy soils through regenerative agriculture, restoring forests and wetlands, and protecting mangroves and seagrasses can sequester carbon while supporting biodiversity and livelihoods. These solutions are often cheaper, safer, and co-beneficial. They may lack the futuristic allure of giant machines, but they work with the grain of nature. In this segment, imagine walking through a restored wetland at dawn. Mist rises off the water, birds chatter in the reeds, and the soil beneath your feet is rich with life. This landscape is quietly absorbing carbon. It is also filtering water, providing habitat, and buffering storms. The same carbon cycle that once inspired fear becomes a source of renewal. Hope is not found in a single invention, but in the convergence of many humble practices. Beyond changing how we generate energy, some propose capturing carbon directly from smokestacks or the air. Carbon capture and storage, CCS, involves collecting carbon dioxide from power plants or industrial facilities and injecting it deep underground into depleted oil fields or saline formations. Reports suggest that cumulative investment in CCS could reach about $80 billion by the end of this decade, and installed capacity may quadruple by 2030. Even so, by mid-century, these systems are projected to capture only around 6% of global emissions. In other words, CCS can play a role, but it cannot replace emissions reductions. Carbon removal technologies aim to draw carbon dioxide directly from the atmosphere or from biomass and lock it away. Their combined capacity could reach roughly 330 million tons per year by 2050. That is significant, but still small compared with the tens of billions of tons emitted annually. Direct air capture, DSC, has captured imaginations. Machines blow ambient air through filters that selectively bind carbon dioxide, which is then concentrated and stored or reused. Yet global DSC capacity today is just over 10,000 tons per year, and most plants are pilot projects. Around 130 facilities are in the pipeline, but scaling to meaningful levels will take decades. Costs remain high, on the order of hundreds of dollars per ton, though they are expected to decline with learning. Investors look for sites with abundant renewable energy and waste heat to power these processes, and some governments offer tax credits to spur development. Still, even optimistic scenarios show DRC capturing only a fraction of what is needed. The lesson is that technology, while exciting, is no silver bullet. It must be part of a portfolio. That includes reducing emissions at the source and enhancing natural sinks, cultivating healthy soils through regenerative agriculture, restoring forests and wetlands, and protecting mangroves and seagrasses can sequester carbon while supporting biodiversity and livelihoods. These solutions are often cheaper, safer, and co-beneficial. They may lack the futuristic allure of giant machines, but they work with the grain of nature. In this segment, imagine walking through a restored wetland at dawn. Mist rises off the water, birds chatter in the reeds, and the soil beneath your feet is rich with life. This landscape is quietly absorbing carbon. It is also filtering water, providing habitat, and buffering storms. The same carbon cycle that once inspired fear becomes a source of renewal. Hope is not found in a single invention, but in the convergence of many humble practices. After exploring technology and policy, we return to the personal scale. Each of us participates in the carbon cycle through our daily choices. Driving or walking, eating beef or beans, buying new gadgets or repairing what we have. These decisions determine our individual carbon footprints. In high-income nations, emissions per person can be several times those in low-income countries. Yet, even within wealthy nations, footprints vary widely. Some people live in small apartments and ride public transit. Others inhabit large houses and fly frequently. Recognizing this diversity helps us avoid blanket judgments and focus on where changes matter most. Choosing plant-rich diets, reducing food waste, and moderating meat consumption lowers emissions because livestock farming produces significant methane. Walking, cycling, or taking public transport reduces emissions from petrol and diesel. Purchasing durable products and repairing clothing or electronics extends the life of materials and reduces demand for new manufacturing. Sharing tools and appliances with neighbors, participating in community gardens, and joining car-sharing cooperatives fosters a culture of sufficiency. These small choices may seem insignificant when billions of tons of emissions are reported each year. Yet, when millions adopt similar habits, markets shift. Demand for plant-based foods encourages farmers to grow more legumes and grains. Demand for energy-efficient appliances drives innovation. Social norms evolve. In many cultures, there is a tradition of valuing simplicity and stewardship. Japanese wabi-sabi embraces imperfection and repair. Indigenous teachings emphasize reciprocity with the land. Scandinavian concepts of lagom celebrate just enough. Drawing from these traditions can inspire modern sustainability. At the same time, we must not place the burden solely on individuals. Systemic changes, from carbon pricing to renewable energy infrastructure, make sustainable choices easier. That said, individual actions can serve as signals. When we show that we value repair, reuse, and reduction, we create space for policies that support these behaviors. We also experience personal benefits. Walking provides exercise. Sharing resources builds community. Cooking plant-based meals can be creative and nourishing. As you listen tonight, consider one small change that could align your lifestyle with the slow rhythms of the carbon cycle. It could be as simple as turning off lights when leaving a room, mending a garment, or choosing local produce. Let this intention settle lightly. Remember that change arises from both the heart and the mind. There is joy in discovering that living gently can enrich our lives. By the end of this series, we hope you will feel empowered to weave your own story into the larger narrative of climate care. The carbon cycle is not only a physical process, it also touches our inner lives and cultures. Throughout history, breathing has been associated with spirit. In Sanskrit, the word prana refers to the vital life force carried by the breath. In Chinese, Kuai refers to the energy that flows through living beings and the landscape. Many indigenous peoples consider the wind to be a messenger, carrying songs and stories. These traditions remind us that air is not empty. It is imbued with meaning. Modern science adds another layer to this understanding. We now know that the composition of the air shapes climate, and that carbon dioxide, though invisible, carries weight. It accounts for about 2/3 of the warming influence of long-lived greenhouse gases. We also know that the air has changed dramatically because of human activity, rising more than 50% above pre-industrial levels. It is humbling to realize that the same gas that nourishes plants can, in excess, disrupt climates and communities. Mindful breathing practices bridge ancient wisdom and contemporary neuroscience. When we slow our breathing and lengthen exhalations, we activate the vagus nerve, which lowers heart rate and calms the nervous system. Meditation, yoga, tai chi, and prayer can cultivate this awareness. These practices do not solve climate change, but they can strengthen resilience and compassion. A calm mind is better able to engage with complex problems without becoming overwhelmed. In moments of anxiety about the future, returning to the breath can provide grounding. Imagine that with each inhalation, you draw in not only oxygen, but also the collective knowledge and care of those working to heal the planet. With each exhale, you release gratitude and intention into the world. Practices like forest bathing, walking slowly among trees and noticing their textures, scents, and sounds reconnect us with the living beings that manage the carbon cycle on our behalf. Studies show that time spent in nature can reduce stress and enhance cognitive function. Philosophers often speak of the air of time, the prevailing spirit of an era. The air of our time is one of both urgency and possibility. Never before have humans been so aware of their influence on the planet. Never before have we had such capacity to change course. Holding these truths together requires both reason and reverence. Reason guides us to understand emissions and sinks, to design technologies and policies. Reverence invites us to respect the invisible threads that bind life. As you breathe tonight, let these perspectives mingle. Picture your breath as part of a global chorus. Each sigh and inhale, a note in an endless song. In that song, there is space for grief, hope, determination, and love. The air carries it all. Carbon's ability to form diverse bonds leads to a stunning variety of structures and materials. In diamond, carbon atoms are arranged in a tetrahedral lattice that makes it one of the hardest known substances. In graphite, carbon atoms are stacked in flat sheets that slide easily over each other. This structure makes graphite an ideal lubricant and the material in pencils. Carbon also forms fullerenes, hollow cages resembling soccer balls, and nanotubes, rolled sheets with extraordinary strength and electrical properties. Carbon fibers, spun from polymers and baked at high temperatures, are woven into lightweight yet strong materials for bicycles, airplanes, and wind turbine blades. Graphene, a single sheet of carbon atoms, has exceptional strength and conductivity. It shows how carbon continues to surprise scientists. Carbon's versatility underlies modern technology as much as it underpins life. Even our understanding of time relies on carbon, a rare isotope, carbon-14, is produced when cosmic rays strike nitrogen in the upper atmosphere. Living organisms continually exchange carbon with the environment. When they die, carbon-14 decays at a known rate. By measuring its remaining concentration in organic materials, scientists can estimate the age of artifacts and fossils. Radiocarbon dating has transformed archaeology and paleoclimatology, allowing us to reconstruct past climates and human histories. In this way, carbon serves as both a clock and a storyteller. Carbon has also been the medium for art and communication. Traditional inks were made from soot and lampblack mixed with gum arabic. Carbon pigment gives India ink its deep black color. Cave paintings from tens of thousands of years ago used charcoal to depict animals and human hands on stone. Early photography relied on film coated with carbon-based emulsions. Each of these technologies shows how humans have used carbon not only to build, but to express. In the human body, carbon makes up about 18% of our mass. It is the backbone of amino acids and sugars. It forms the rings of cholesterol and hormones. It is present in every cell membrane. When we exhale carbon dioxide, we are not losing a part of ourselves, but releasing a waste, product of cellular respiration. That molecule will likely be taken up by a plant, incorporated into a leaf or trunk, eaten by an herbivore, and perhaps someday returned to us in a different form. Contemplating this transforms waste into a gift. It also highlights the continuity between our bodies and the planet. As you lie here, imagine the carbon in your bones once forming part of a shell in an ancient sea. Imagine the carbon you exhale becoming part of a grain of wheat. Realizing this continuity can bring comfort. We are not separate from the cycles we study. We are made of them. Time is another thread woven through the carbon story. When we burn a piece of coal or a drop of oil, we are tapping into sunlight captured by plants hundreds of millions of years ago. The carbon in fossil fuels was sequestered by ferns, algae, and plankton in ancient swamps and seas. It then lay buried and compressed under sediments, slowly turning into coal, petroleum, and natural gas. These resources were not meant for our instantaneous use. They are part of Earth's long-term carbon storage. When we extract and burn them, we collapse geological time into human time. A gallon of gasoline releases in minutes the carbon that took nature millions of years to store. This mismatch between timescales partly explains why the atmosphere struggles to adapt. We are asking the carbon cycle to process eons of carbon through contemporary forests and oceans, which cannot keep up. Yet this awareness does not have to be paralyzing. It can inspire awe and motivate care. Modern data quantify the magnitude of this mismatch. Energy-related carbon dioxide emissions in 2024 were about 37.8 billion tons, contributing to an atmospheric concentration that has risen over 50% since 1800. At the same time, natural sinks continue to absorb roughly half of our emissions. This means that every ton we avoid emitting buys time for these sinks to function. Our individual actions may seem small compared with billions of tons, but they accumulate. Moreover, acting mindfully can provide a sense of agency. Repairing and reusing household items means fewer emissions from manufacturing, replacements, choosing slower modes of travel, and supporting policies that promote renewable energy. Amplify your influence. Each act is a tiny adjustment to the narrative arc, a way of respecting the difference between human and geological time. Reflecting on time also invites us to slow down. Modern culture often prizes speed, fast cars, express shipping, quick consumption. In contrast, forests grow slowly, soil forms over centuries, and coral reefs build themselves one calcium carbonate grain at a time. Aligning our lives with these natural rhythms can bring peace. Try pausing before making a purchase to consider whether you really need the item. Take time to cook a meal from scratch. These practices cultivate patience and gratitude. They remind us that we are temporary, stewards of carbon that has passed through countless bodies and will continue long after us. There is comfort in becoming part of a continuum. As you listen, picture the timeline of Earth stretching from fiery beginnings to distant futures. Our era is a thin slice, yet our choices ripple through that immense span. What legacy will we leave? That question is not meant to create anxiety, but to awaken purpose. We have inherited a story billions of years in the making. We have the privilege of adding a new chapter. Climate change is not merely an environmental issue. It is also a question of justice. The impacts of warming, from floods and droughts to heat waves and food insecurity, disproportionately affect those who have contributed least to greenhouse gas emissions. Low-income countries and marginalized communities often lack resources to adapt or recover. Many island nations face rising seas despite emitting a tiny fraction of global carbon. People living in poverty are more exposed to climate hazards and less able to move or rebuild. At the same time, wealthy nations have historically emitted far more carbon per person and have built their prosperity on fossil fuels. Recognizing this imbalance, the concept of climate justice calls for solutions that reduce emissions while addressing inequity. It emphasizes that the transition to a low-carbon economy must be fair and inclusive. It advocates for financial support from high-emitting countries to help vulnerable nations and communities adapt to climate impacts. At international climate negotiations, this principle is taking concrete form. Discussions about loss and damage. Funds aim to compensate countries for irreversible harms caused by climate change. There are calls for debt relief so that low-income countries can invest in resilience rather than interest payments. Climate finance for clean energy and adaptation is increasing, but it remains far below what is needed. Ensuring that money reaches those who need it most requires transparency and accountability. Within nations, a just transition means supporting workers and communities whose livelihoods depend on carbon-intensive industries. For coal miners and oil field workers, the energy transition can be frightening. Policies that provide retraining, income support, and community investment ease the shift. Empowering workers through unions and cooperatives ensures that they have a voice in the process. Justice also concerns procedural fairness. Who gets to make decisions about land, water, and energy? Indigenous peoples and local communities often steward biodiversity and carbon sinks. Yet, they have historically been excluded from policy discussions. Recognizing land rights and traditional knowledge not only rectifies past injustices, but also leads to better outcomes. Supporting women's leadership in climate action recognizes their crucial roles in food systems and water management. Creative campaigns, from climate-focused art to divestment initiatives, raise awareness and shift cultural norms. As you listen to this segment, consider how justice appears in your own life. Do you have access to clean air and water? Do your neighbors? Are there ways to align your actions with fairness? Climate justice invites us to expand our circle of concern, to see that protecting the atmosphere and protecting people go hand in hand. By centering equity, we not only address climate change more effectively, but also build a world where all can thrive. As we near the midpoint of our narrative, we explore how carbon not only builds physical structures, but also carries culture. The earliest artists used carbon in the form of charcoal and soot to draw animals and handprints on cave walls. These images, tens of thousands of years old, still speak to us across time. In ancient China and India, lamp black mixed with gum arabic became ink, allowing scribes to record poems, histories, and scientific treatises. Carbon pigments made from ground bones and vines created the deep blacks in Renaissance paintings. In the 19th and 20th centuries, photographers captured light on film coated with carbon-based emulsions, preserving moments on celluloid. Vinyl records, magnetic tapes, and compact discs all rely on carbon-derived materials to store sound. Even today's digital devices use carbon-based components. Silicon chips are encapsulated in carbon-filled plastics, and lithium-ion batteries use graphite anodes. Carbon is not just a component of art. It is a medium through which stories, music, and images travel. Science, too, uses carbon to tell stories. Radiocarbon dating, mentioned earlier, reads the ratio of carbon-14 to carbon-12 to reveal the ages of artifacts. Carbon fibers and nanotubes enable microscopes, telescopes, and satellites to be lighter and stronger, opening new windows onto the universe. Graphite electrodes enable medical imaging. In laboratories, organic chemists weave carbon atoms into new molecules that become pharmaceuticals, plastics, and dyes. In climate science, carbon dioxide measurements are the language through which we understand change. Researchers share their findings through papers, lectures, and documentaries, which in turn inspire artists and activists. The boundary between art and science is porous. Both disciplines observe, interpret, and communicate. Both ask questions about our place in the world. Imagine a painter and a physicist sitting in the same cafe, each stirring coffee with a carbon-based spoon. One considers the play of light on a landscape. The other ponders the absorption spectrum of carbon dioxide. They are not as different as they might seem. Each is translating experience into a form that others can grasp. The carbon molecules in their pencils and instruments are tools of translation. Storytelling is itself a carbon-based process. The air that carries our words contains carbon dioxide. The paper that holds our letters comes from trees. When you listen to this podcast, your device converts electrical signals into sound waves by moving a membrane, often made of plastic, a hydrocarbon. At every turn, carbon enables connection. Reflecting on this, you might find comfort in knowing that learning about climate change and creating art share the same substrate. Our capacity to communicate, imagine, and act is tied to the same element that we are striving to balance. In celebrating carbon's role in culture, we also recognize our responsibility to steward it wisely. In the quiet middle of our night journey, we pause to listen to the long rhythms of the planet. Climate is not a snapshot, but a slow conversation among oceans, forests, and ice over millions of years. Species migrate and adapt. When the land warms or cools, forests shift northward. Coral reefs bleach or flourish. Cities, too, must learn to sway with the winds. Scientists study tipping points, thresholds at which a subtle nudge can set in motion cascading change. One such threshold is the amount of carbon dioxide we continue to release. Today, projects to capture and store carbon are stepping beyond pilot stages. Reports estimate that global investments in carbon capture and storage will reach about $80 billion by the end of this decade, and capacities will quadruple by 2030. Even by mid-century, however, these systems are expected to capture only about 6% of global emissions. Carbon removal technologies like direct air capture or biochar might remove hundreds of millions of tons by 2050, yet they remain a small next to the steady river of emissions. A few dozen direct air capture plants worldwide currently collect on the order of 10,000 tons per year, and most are in their first years of operation. Costs of pulling carbon directly from air remain high, hundreds of dollars per ton, though learning curves promise future declines. Analysts project that costs could drop by around 40% by 2050. Some governments, like Canada, offer tax credits to spur innovation, and developers seek locations where renewable electricity and waste heat are plentiful. Yet, even with subsidies and policy support, these technologies are not silver bullets. We share this not to diminish hope, but to place it within scale. If climate is a symphony, these technologies are a single instrument, important, growing, yet not the whole orchestra, restoring forests and wetlands, protecting peatlands, and farming in ways that build soil. Carbon, each of these actions, is a note in the ensemble. Together, they weave resilience and draw down carbon through living cycles. They also remind us that solutions are most effective when they honor the pace and complexity of nature. As we imagine tomorrow, let us picture landscapes recovering, rivers running clear, and communities finding work in restoring rather than extracting. The coming years will be about weaving technology with stewardship. Nothing moves quickly in the language of ecosystems, and yet change does come. When we align our hands with these slower rhythms, our actions reverberate long after we are gone. In this way, hope becomes less an abstract concept and more a practice, a daily choice to plant seeds, to mend, and to trust in collective effort. The next movement in our story turns toward the massive transformation underway in how humanity powers its world. Energy is often described as the lifeblood of civilization, and it has largely been fed by fossil fuels. This reliance has made the energy sector the source of roughly 73% of global greenhouse gas emissions. Decarbonizing this sector is therefore central to meeting climate goals. Recent analyses show that global energy investment is shifting rapidly. Of the roughly $3.3 trillion expected to flow into energy in 2025, more than $2.2 trillion is set to go toward clean technologies. Solar panels, wind turbines, nuclear reactors, power grid upgrades, and efficiency measures. Solar power alone is projected to attract around $450 billion in investment, while spending on nuclear energy may exceed $70 billion. To put that in perspective, clean energy investment is now roughly double that of fossil fuel investment, and about 70% of the growth comes from countries that have historically imported their fuel. Today, net zero pledges by governments and companies cover about 70% of global emissions and gross domestic product. Achieving these promises will require the share of electricity supplied from clean sources to reach 90% by mid-century. Studies suggest wind generation must scale roughly 11-fold and solar 20-fold by 2050. Individual countries have set ambitious targets. The United States aims for 80% clean electricity by 2030 and 100% by 2035. Canada has legislated climate targets and uses carbon pricing and electric vehicle infrastructure to drive change. These numbers illustrate a trend. The center of gravity in energy is moving from extraction to conversion, from burning to capturing sunlight and wind. In the world's deserts, shimmering arrays of panels follow the sun. Offshore, blades taller than skyscrapers harness steady breezes. Rivers, geothermal vents, and atomic forces quietly turn turbines. Energy storage in batteries, pumped water, or subsurface heat allows these flows to match our demand patterns. The shift is not just about technology, it is about fairness and access. Clean energy often means lower costs and less pollution for communities historically burdened by power plants. It can bring jobs to rural areas and independence to nations dependent on imported fuels as night stretches on. Imagine a future where the hum you hear outside is from an unseen wind farm, where rooftops are gardens and power plants are forests of gently turning blades. When we choose this future, we honor both the science and the stories we tell about ourselves. While decarbonizing energy and capturing carbon are vital, the way we live and care for land also shapes the climate. Agriculture, forestry, and the way we eat contribute both to emissions and to solutions. When soils are plowed deeply and monocultures dominate, carbon stored in the ground is released to the air. Conversely, regenerative practices, planting diverse crops, minimizing tillage, and integrating animals can turn farms into carbon sinks. Wetlands and mangroves sequester carbon at rates far higher than terrestrial forests, and protecting them also buffers storms and nurtures fisheries. Indigenous peoples have long managed landscapes in ways that respect cycles of fire and growth. Their knowledge is now informing modern restoration projects. At the household level, the choices we make ripple outward. Choosing plant-rich diets, reducing food waste, repairing objects, rather than replacing them and sharing resources all lower demand for new production and thus emissions. It may seem like the acts of one person cannot register against global numbers, but behavior shapes markets. When millions choose efficient appliances or electric vehicles, manufacturers respond. Policy often follows practice. Community gardens inspire city councils to green laws. Bicycle lanes grow where enough cyclists ride. Climate action begins as a personal practice and expands into cultural change. Many people wonder how much their choices matter when large emitters continue business as usual. Here, the data provide guidance. Even if carbon capture and clean energy investments scale, these alone cannot meet climate goals. Analysis project that the cumulative capacity of carbon capture technologies will rise dramatically, but by 2050, they will still be capturing only about 6% of global emissions. Carbon removal may sequester around 330 million tons per year by mid-century, meaningful yet far from the tens of billions we emit annually. Renewable energy investments will keep growing, but energy demand also continues to rise as billions aspire to modern comforts. Therefore, reduction and efficiency remain paramount. When we insulate homes, design buildings to capture natural light and breezes, adjust thermostats, and accept slower journeys via train instead of plane, we reduce the need for new energy generation. When we buy fewer but better things, we cut the emissions embedded in supply chains. These small decisions accumulate. They also create cultures of sufficiency, a quiet contentment with enough. In the soft hours of this narrative, notice how your breathing slows when you release the desire for more. The world we build is as much about inner values as outer infrastructure. Remember that our dwellings and their design can either waste energy or harvest sunlight and breezes. In designing and caring for them, we participate in climate action without leaving home. Our story now turns to the social dimensions of climate. Not all societies have contributed equally to atmospheric change, yet the consequences are distributed unevenly. Wealthier nations have historically emitted far more carbon per person and have benefited from the energy that resulted. Meanwhile, many vulnerable communities have emitted little but face the greatest risks from rising seas, droughts, and storms. Research shows that global emissions have grown rapidly over the past 50 years, yet per capita emissions vary widely. Some countries have reduced domestic emissions while others continue to grow. Climate justice is therefore an essential part of any pathway forward. This concept recognizes that solutions must address inequities, supporting those who have been least responsible and yet most affected. It includes funding to help low-income countries develop clean energy, adapt to extreme weather, and recover from damages. During international climate negotiations, the idea of loss and damage funds is beginning to take shape. Decarbonization must also be a just transition for workers in fossil fuel industries. Coal miners, oil field workers, and refinery staff have built our modern world. Fairness requires providing training and opportunities in new sectors, rather than leaving communities behind. When done well, clean energy projects can revitalize regions with good jobs. But when done poorly, they can replicate patterns of exploitation. Justice extends beyond humans. A changing climate threatens ecosystems that cannot migrate or adapt quickly. Protecting biodiversity ensures that forests continue to absorb carbon, soils retain water, and pollinators sustain food crops. Indigenous and local communities often act as guardians of biodiversity, recognizing land rights and traditional knowledge is not just ethical but effective climate policy. On an individual level, practicing justice means noticing where our resources come from and advocating for fair conditions for those who produce them. It means supporting policies that reduce emissions while addressing poverty and inequality. In this part of the night, we imagine a world where climate solutions are also peace-building exercises. They foster empathy and connection across cultures. Art and storytelling play a role here. Music, film, and literature open hearts in ways statistics cannot. When we listen to voices from the front lines of climate impacts, farmers describing failed rains or islanders watching shorelines disappear, we feel motivation to act. Recognizing our shared vulnerability can be a bridge between worlds. As we drift deeper, let us hold space for the wisdom that emerges when science and social conscience intertwine. And let us remember that our actions in high-emitting nations have outsized impact on global trajectories, while solidarity empowers others to leapfrog to cleaner futures. Our story now turns to the social dimensions of climate. Not all societies have contributed equally to atmospheric change, yet the consequences are distributed unevenly. Wealthier nations have historically emitted far more carbon per person and have benefited from the energy that resulted. Meanwhile, many vulnerable communities have emitted little but face the greatest risks from rising seas, droughts, and storms. Research shows that global emissions have grown rapidly over the past 50 years, yet per capita emissions vary widely. Some countries have reduced domestic emissions while others continue to grow. Climate justice is therefore an essential part of any pathway forward. This concept recognizes that solutions must address inequities, supporting those who have been least responsible and yet most affected. It includes funding to help low-income countries develop clean energy, adapt to extreme weather, and recover from damages. During international climate negotiations, the idea of loss and damage funds is beginning to take shape. Decarbonization must also be a just transition for workers in fossil fuel industries. Coal miners, oil field workers, and refinery staff have built our modern world. Fairness requires providing training and opportunities in new sectors, rather than leaving communities behind. When done well, clean energy projects can revitalize regions with good jobs. But when done poorly, they can replicate patterns of exploitation. Justice extends beyond humans. A changing climate threatens ecosystems that cannot migrate or adapt quickly. Protecting biodiversity ensures that forests continue to absorb carbon, soils retain water, and pollinators sustain food crops. Indigenous and local communities often act as guardians of biodiversity, recognizing land rights and traditional knowledge is not just ethical but effective climate policy. On an individual level, practicing justice means noticing where our resources come from and advocating for fair conditions for those who produce them. It means supporting policies that reduce emissions while addressing poverty and inequality. In this part of the night, we imagine a world where climate solutions are also peace-building exercises. They foster empathy and connection across cultures. Art and storytelling play a role here. Music, film, and literature open hearts in ways statistics cannot. When we listen to voices from the front lines of climate impacts, farmers describing failed rains or islanders watching shorelines disappear, we feel motivation to act. Recognizing our shared vulnerability can be a bridge between worlds. As we drift deeper, let us hold space for the wisdom that emerges when science and social conscience intertwine. And let us remember that our actions in high-emitting nations have outsized impact on global trajectories, while solidarity empowers others to leapfrog to cleaner futures. We return to the macro scale, charting the pathways toward net zero emissions by mid-century. Achieving net zero means balancing any remaining emissions with removal, effectively halting the rise in atmospheric greenhouse gases. Studies outline how this could unfold. Rapid deployment of all available clean energy technologies, electrification of transport and heating, and massive efficiency gains. The energy sector, responsible for the vast majority of emissions, must reach near complete decarbonization. Clean electricity will need to supply 90% of demand by 2050, supporting electric vehicles, heat pumps, and industrial processes. Wind and solar will scale dramatically, complemented by hydro, geothermal, and advanced nuclear. Existing nuclear capacity must be maintained and new reactors built carefully to ensure safety. Hydrogen produced from renewable electricity can provide fuel for aviation, shipping, and steelmaking. Carbon pricing, which charges polluters for each ton of emissions, creates economic incentives to invest in low-carbon technologies and reduce consumption. Electric vehicle charging networks, public transit, and active transportation infrastructure make it easier for individuals to choose low-carbon mobility. Government policies such as standards for building efficiency and bans on combustion engine sales send clear market signals. International cooperation is essential to share technology and finance with developing countries so that they can leapfrog to clean systems. Across all scenarios, demand reduction through sufficiency is key. Even if renewable energy expands tenfold, runaway consumption could outstrip its benefits. Net zero pathways also recognize the need for resilience, adapting to impacts already locked in, seawalls, floodplain restoration, and urban green spaces mitigate heat and rainfall extremes. Rural water storage and drought-resistant crops help farms cope. Smart urban design, like tree-lined streets, reflective roofs, and shaded courtyards, reduces energy demand and sequesters carbon. Planting trees along city streets cools microclimates and provides habitat for birds. In the end, the path to net zero is both technical and cultural. It involves engineers designing new reactors and artists reimagining our relationship with growth. It invites policymakers to set ambitious targets and families to embrace new norms. The world will not flip a switch overnight. Instead, millions of small changes, coordinated through shared vision and policy, will gradually tip the balance. Imagine looking back from a future where fossil fuels are curiosities in museums. The air is cleaner, the seas calmer, and children learn about the carbon crisis as a story of how people came together. That vision can guide our choices today. As we near the end of this journey, our focus narrows inward. Throughout this story, we have spoken of forests, oceans, technologies, and policies. Now we return to breath. Breathing is a constant dialogue between our bodies and the atmosphere. Each inhalation brings oxygen to fuel our cells. Each exhalation carries carbon dioxide back to the air, where plants and plankton will eventually assimilate it. The air we breathe has traveled through countless lungs before ours. It may have brushed past the leaves of a rainforest, the gills of a whale, or the chimneys of a factory. Realizing this interconnectedness can foster humility and care. Many contemplative traditions anchor attention on the breath to cultivate presence. In yoga, pranayama teaches that conscious breathing can calm the mind. In meditation, following the breath returns awareness to the present moment. Neuroscience now shows that slow, rhythmic breathing can lower heart rate and activate the body's rest and digest response. In a world buzzing with urgency, these practices are not indulgences, but vital acts of self-regulation. They can help us face the climate challenge without being overwhelmed. As you lie in the dark, notice the subtle rise and fall of your chest. Feel how your breath blends with the story of carbon. Each time you exhale, you contribute to the ancient cycle that sustains life. Over centuries, atmospheric carbon dioxide levels have risen more than 50% from pre-industrial values to around 420 parts per million, and this gas accounts for about 2/3 of the warming influence. That knowledge can feel heavy, yet our individual exhalations are not the problem. It is the large-scale burning of fossil fuels. Recognizing this difference can relieve unhelpful guilt and redirect attention toward systemic change. Imagine the molecules you release joining the global journey we have described. This mindful attention can turn abstract numbers into felt experience. It reminds us that the solutions to climate change are not only out there in technologies and policies, but also within us. We can cultivate patience, compassion, and resilience. These qualities enable us to sustain engagement for the long term. When we treat ourselves and others with kindness, we create space for cooperation and collective action. The challenges are significant, but they do not exist outside the fabric of everyday life. Each choice we make, what to eat, how to travel, how to speak, either perpetuates old patterns or seeds new ones. In this segment, we rest in the quiet between actions, trusting that listening deeply can inform wiser actions when dawn arrives. As dawn hints at the horizon, take one more breath, slowly, consciously, and feel how intimately you are woven into the air that encircles the globe. Our final segment is a gentle closing, a bringing together of the threads woven through this hour. We began with the cosmic origin of carbon, traced its cycles through rocks, oceans, and respiration, and followed humanity's imprint as we dug ancient fossils and burned them to light our nights. We explored the science of greenhouse gases and the evidence from ice, cores, and satellites. We wandered across ecosystems and cities, listening to the rise of renewable energy, the promise and limitations of carbon capture, and shifts toward sufficiency and justice. Along the way, we breathed with you, sometimes slowly, sometimes deeply, always aware of the invisible exchange sustaining us. We reflected on the profound inequities that make some people and species more vulnerable than others, and highlighted how solutions are opportunities to heal not just the atmosphere, but our relationships with one another and the earth. We examined the immense economic shifts toward clean technologies, noted the scale of investment and the policies driving change. We acknowledge that technologies alone cannot save us. Personal choices and cultural transformations matter too. We learned that forests and oceans absorb large fractions of our emissions, and that protecting and restoring them is one of the most powerful actions we can take. Throughout, hope has been not a blind optimism, but a grounded practice, informed by data and shaped by empathy. As we arrive at this moment, notice again your breath. Feel the weight of your body supported by the bed, the softness of sheets, the coolness of air. Outside, the night carries its own rhythms. Somewhere, winds turn turbines. Somewhere, seedlings unfurl. Somewhere, engineers refine reactors and activists organize gatherings. The work continues even as you rest. That is the beauty of collective effort. It does not rely on any one person alone. Our closing invitation is simple. Let this story settle into your subconscious like rain on parched soil. Tomorrow, you may remember a line or an image, or maybe just an impression of calm. Let that inform your actions. If you feel anxious, return to your breath. If you feel inspired, share the story with another. The earth will keep turning. The carbon cycle will continue its ancient dance. And we, a small yet conscious part of this system, can choose to act with care. May these thoughts accompany you into sleep, reminding you that your awareness and your choices matter. Rest now. The night is deep, and the world around you whispers possibilities. According to the SleepWise production blueprint, an episode is composed of 20 segments of about 2,800 to 3,000 characters each. This episode has followed that pattern, guiding you through science and story in equal measure. Thank you for listening and for caring. Good night.